Hi, welcome to Code with Z. In today's video, we gotta find this target number that we have here inside this array in an efficient way. Why? Well, because that's what LeetCode 81, search and rotated sorted array 2 is asking us to do. Now, this is a lengthy explanation, so I'm just gonna simplify it for you. Long story short, let me bring this down here and put this here, and let's make this a little bit bigger. What the question is telling us is that this array used to be this, and we have rotated it. As you can see, 1, 6, 6, 6, 6 till the end, right? And this is the 1, 1, 1, 6, 6, and then we come here. This 6 here is literally this 6 down here. So as you can see, the array was rotated, and because of that rotation, we ended up with this array that we have here. But the original array was sorted. As you can see, this is a complete sorted array. And then obviously, we are also allowed to have duplicates. Now we gotta look for the target number that we have here inside this rotated sorted array. And we have to do it efficiently. So we're basically searching for a target number inside of an array in an efficient way. Now, I don't know about you, but each time I hear searching, efficient, sorted, I always think of binary search. But the problem is, binary search works in a proper sorted array. Our array was originally sorted, but because of that rotation, it's not sorted anymore. As you can see, some parts of it is sorted. For example, this part is sorted, or like we can even take this part. These numbers are all equal to each other and they're all next to each other, so it is sorted. So because of this, we can see that we can have binary search, but we can't just have the classical old binary search. We have to make some tiny modifications to it that it will work with our rotated array, because not all of the parts of our array is sorted. So for example, we go from 6 to 1. This is obviously not sorted because after we go from 1 to 6. So let's see how you can solve this. So because we have binary search, we obviously need our important variables. The first one is going to be left. That's going to be equal to 0, meaning it's going to be pointing to the position of the first element inside of our array, meaning 0, because the position of this element here is 0. And then we have right, which is going to be equal to the position of the last element inside of our array, which is this number here. So right is equal to 0, 1, 2, 3, 4, 5, 6, 7. So right is equal to 7. Now that we have our left and right, in binary search, we also need to have our middle variable. Middle is going to be always equal to left plus right divided by 2. Well, left is 0, right is 7. 0 plus 7, that's going to give us 7. 7 divided by 2, that's going to be 3.5. We're going to get rid of this 0.5 here, so that's going to leave us with 3. So middle is going to be pointing to the number with the position of 3, and that's going to be this 6, because this position here has the index of 3. Now that we have our middle number, in classic binary search, we're going to be like, is the number that mid is pointing to equal to our target number? So let's check. We're going to say, is 6 equal to 1? Is the number that middle is pointing to equal to our target number? Unfortunately, it's not. Okay, so far everything was classic binary search. Now we're gonna add our tiny simple touches to our algorithm. We're gonna be like, okay, we checked if the middle is pointing to the number that we are looking for. If that was not the case, we're gonna do this. We're gonna be like, is left and medium and right are all pointing to the same number? So is the number that left is pointing to equal to the number that mid is pointing to? And is the number that mid is pointing to equal to the number that right is pointing to? Well, yeah. Why are we checking this? Well, because not all parts of our array are sorted, but like some parts of our array are actually sorted, right? So we need to actually check the values of left and mid and right to see which part of our array is sorted. But because now left and mid and right are all pointing to the same, we can't tell which side of our array is sorted. So for example, if I pick this side as sorted, I might be correct. But like if I pick this side is not sorted. And there's no possible way for me to figure that out, because if these numbers were not equal to each other, I could easily figure that out. And you're going to see that in the next round. But because these are all equal, we're just going to increment left and decrement right, like so. Now left is pointing to this number, and right is pointing to this number, and then we're going to calculate our middle again. We're going to be like, middle is equal to left plus right divided by 2. Now left is 1 because it got incremented. Previously it was 0, and then right is 6. Previously it was 7, and it got decremented. Now 1 plus 6, that's 7. 7 divided by 2, that's going to give us 3.5. We're going to get rid of this decimals here, and that's going to give us 3. Now middle is pointing to this number. We're going to check if the number that middle is pointing to is equal to our target. Unfortunately, it's not. And then we're going to be like, are these three pointing to the same numbers? Well, left is pointing to 6, mid is pointing to 6, but right is pointing to 1. That's awesome. That means we can actually check to see which side of our array is sorted. We're going to be like, okay, is the left side sorted? Well, left is pointing to 6 and medium is pointing to 6. So left is smaller or equal to mid. That means it is sorted. Awesome. And if we were to start with the right side, we would say, is the number that middle is pointing to smaller or equal to the number that right is pointing to? Because that's how it should be in a sorted array, right? Well, 6 is not smaller than 1. That means this side is not sorted. So we're just going to come back to the left side. So now that we know our left side is sorted, we're going to check if the target number lies between the range of our left side from the left side all the way until the middle. But we're not going to check the middle because we already checked it when we said, is the number that mid is pointing to equal to our target? And it wasn't. So we've already checked this. So we're going to be like, does the target number lie in this range? And we can check the range and we can actually ask this because we know this side is sorted. So you can easily say, is target between the number that left is pointing to all the way to the number that middle is pointing to? We can easily say this because we know this part is sorted. When we check, we realize that the number does not lie on the left side because 1 is not in this range and we can see it clearly. So we're going to be like, okay, that means the number is not on this side. So we're going to say left should be equal to middle plus 1. Like so. Now left is pointing to this number and right is pointing to this number. Again, we're going to calculate our middle. We're going to say middle is equal to left plus right divided by 2. 4 plus 6 divided by 2, that's going to give us 10. 10 divided by 2, that's going to give us 5. Now middle is going to be pointing to this number here. We're going to check if 6 is equal to target number. It's not because target number is 1. So we're going to check if we have duplicates. We're going to say, is the number that left is pointing to equal to the number that middle is pointing to? And is the number that middle is pointing to equal to the number that right is pointing to? Thank God not. Because 6 is equal to 6, but 6 is not equal to 1. So you can actually check to see which side is sorted. The number that left is pointing to is smaller or equal to the number that middle is pointing to. So we know that the left side is sorted. We're going to say, does our target number lie between this range? Well, it doesn't because target is 1 and the smallest number we have here is 6. So we're going to be like, okay, then left should be equal to middle plus 1. Now left is going to be pointing to this number and we got to calculate our middle number. We're going to say mid is equal to left plus right divided by 2. That's going to give us 6 plus 6. That's going to be 12. 12 divided by 2. That's going to give us 6. Middle is going to be pointing to this number here. And then we're going to check if the number that middle is pointing to is equal to our target. Well, 1 is equal to 1. Thank God, that means we have an answer and this is going to be it. So just like you saw, each time we're going to calculate our middle, we're going to check if we have duplicates and we're going to find the sorted side and we're going to update our left and right variables accordingly. Now let's code this in the simplest way possible. Alrighty, let's code this together. So the first thing that we need to do is to define our left variable and that's going to be equal to 0. Then we have to define our right variable and this is going to be equal to the index of the last element inside of our array. So nums.length minus 1 because our array is nums. That was given to us. And then we have our loop. We're going to say while left is smaller or equal to right, we want to keep on looping like so. Here we're going to have the logic that we saw on the slides. If we find the number, we're going to return true. And if not, we're going to return false. So if we didn't actually find the answer that we have here inside this loop, that means the number does not exist. So we're going to return false at the end. Now let's see how we can actually look for our number. So the first thing that we need to do is to define our mid variable. And this is going to be equal to left plus right, just like we saw on the slides, divided by 2. But we don't want to have any decimals, so we're going to wrap this around math.floor, like so. And that's going to get rid of our decimals. And then we're going to check if the number that middle is pointing to is equal to our target. If that's the case, just return true. Now, we have to check if we have duplicates. So we're going to say else if the number that left is pointing to is equal to the number that middle is pointing to, and the number that middle is pointing to, let me drag this to the left like so, is equal to the number that right is pointing to, we need to update left and right. We're going to increment left and decrement right, just like we saw on the slides. Now, if we don't have duplicates, we have to check which side of our array is sorted. So we're going to say else if, we have to check if the left side is sorted. So we're going to say nums at the index of left is smaller or equal to the number at the position of mid, because if the number at the left side is smaller or equal to the number at the middle side, that means that part of our array is sorted. So if it is sorted, we're going to check to see if we can actually find our target number in that side. So we're going to say if nums at the index of left is smaller or equal to target and target is smaller than nums at the index of mid, that means the answer that we look for is on the left side. So we're going to say right should come to the left side. So right should be equal to mid minus 1. And if that was not the case, we're going to say else left should be equal to middle plus 1, just like we saw on the slides. We realized that the number that we were looking for was not on the left side, so we sent left to the right side. We sent left to middle plus 1. Now this part is assuming that our left side was sorted. If that was not the case, meaning if our left side was not sorted, if our right side was sorted, we're gonna have something similar. Here we're assuming that the right side was sorted, so we have to check to see if the target number lies in the range of our right side. So we're gonna say the number that the middle variable is pointing to is smaller than our target, and target itself is smaller or equal to nums at the index of right. That means our target is on the right side, so we have to bring left to middle plus 1. And else, meaning our target is not on the right side, so we need to send right to middle minus 1, like so. Now let me zoom out one more time, and this is gonna be all of our code. I hope I have not made any typos. Let me run this and see if we can actually get accepted. Moment of truth, and yep, awesome. Let me submit this and see if we can actually pass all of the test cases. And yep, that's awesome. Thanks for watching. Don't forget to like and subscribe and keep on coding.